Good morning all. So today I'm going to test, as if it doesn't fall off my bench, my EasyEVSE. This is the simple CMOS and comparator circuit, sending a 1 kHz square wave out to the car, and the relays, of course, transferring mains out to the car's charging socket. So without further ado, let's get straight on with it and see if it works. So this is what I'm going to use to provide mains to the EVSE and onto the car. This is the Bluetti AC200. Now I've charged it up to 100%, so I'll probably completely empty this power bank into the car, and we'll see how many additional miles we get. I've made up a couple of cables. Well, I had the commando cable there, but I've made this one, which has a 10 amp inline connector, although this thing's pretty horrible inside. The only reason for that is so that I could get it through the letterbox, so that I can shut the door but have the EVSE outside the house. So outside I've got a plug in a socket that comes down to the commando plug, which is the plug that was on my EVSE. Here's the EVSE with my analog circuitry and lights on the relay, so we should be able to see if those light up. And then that runs down here to the plug, which is going to go in the car's socket. So this is the car. This is an MG ZS EV electric car. It's currently charging from the household mains using the MG EVSE that came with it, which is this one, but that's just plugged into a rather pathetic extension lead which I got from Lidl and it's 25 meters long. It's really very excessive in length, and I've estimated that I'm probably losing about 300 watts just in that cable warming up. Right, so let's get inside the car. I'll need to switch on the electronics. There's a start-stop button here. Oh, of course I'll need to put my foot on the brake when I do that. Otherwise we don't get the full electronics coming on. Because I need to stop the charging from the current charger. Oh, need to turn the sound off otherwise. So that's saying charger is connected, you can't go anywhere. I'll okay that. So we come down onto here, let's look at the battery screen, and it should say that it's charging at 14, oh no, that's plus 14 amps because the heater's come on. I'll turn the heater off actually, because we don't need the heater on. That's just going to draw masses of power from the battery. Right, the heater's off. Let's go back to the battery screen. We should have a negative amount, yeah, minus 4 amps going into the car. That's not a lot, is it? And that's 4 amps, of course, at 356 volts, so it's not 4 amps at mains. But anyway, I'm going to finish charging. That should mean I can pull the plug out of the front of the car. Oh yeah, I heard the relay click. So the plug should now be released. I can pull it out and put my plug in from my EVSE. Right, so let's hoik this one out. There's a little bar graph here, so it's saying 2 bars. That means it's under 50% full. We'll have a look at the mileage actually, because before I switch on this charger, oh, I've got to try and get this bung off the end of the plug now with one hand, which is tricky. Let's plug that one in. Now the lights come on. It's not because it can see any power, because it can't. What it can see though is a resistor on the PP pin, the proximity pilot pin, down to ground. So it knows there's a connector in there, but there's no square wave on there, on the CP pin, and of course there's no mains. So we'll just do a quick check of the car's estimated range, and then I'll switch on the power bank. And here in the car's at 49% battery, and it has 96 miles of range. And that's quite good, because I'm estimating that fully emptying that power bank, which is I think about 1350 watt hours, 1.35 kilowatt hours, should give this car about an extra 4 miles of range, so we should be looking at taking it up to 100 miles of range. Okay, back in the house, let's turn on the AC on. So the AC is on now. We should see, if it starts to charge, a power amount. Oh, it's gone up to 174, and it's gone up to 1500 watts, and the fans come on. You can hear the fan running, although it's a bit erratic, which is odd. Let's go and take a look at the EVSE. In fact, I'll keep this shot running. And there's the cat. And yeah, the green lights are on the EVSE, so that is working in the sense that the relays are on. Let's take a look from inside the car. First thing to do, of course, is just touch the metalwork of the car, make sure I can't feel anything. This is a non-earth, non-grounded system completely. From the power bank to the car, nothing is grounded, but no, there's no buzzing feeling. So let's get inside here and see what it says. Oh well, the amps is tiny, minus 3 amps. That means it's charging with 3 amps, but of course that's 3 amps at 356 volts. The EVSE is set to pull 6 amps at mains, so it's pulling 6 amps at mains, 2/3 amps at 356 volts, and we're looking for the mileage to increase by about 4 miles, I believe. And on the driver display you've got similar numbers. Can't see the power or the current and voltage at the moment. Yeah, there's current and voltage. Voltage 356 volts, current minus 3 amps. Estimated range 96 miles, bottom left there, and battery percentage 49% on the bottom right. Okay, let's go and look at the power bank. Well, a quick pit stop at the EVSE. I've left the lid off because there's no chance of rain today. I suppose the cat might sniff the yeah, I don't want to think about that. Anyway, the green lights are on, the relays are clearly on, and on the power bank, already down to 93%. For this power bank, 1500 watts is quite a high power pull. I mean, it will do 2 kilowatts from the pure sine wave inverter, so we're running at 3/4 maximum power, but that's a fairly consistent 1500 watts. Now at 230 volts, which I believe this is, actually I think we can see it. Data, oh, where is it? Inverters and charger, AC output, yeah, 230 volts, 6.5 or 6.6 amps here. So we did see, didn't we, that the pulse width was slightly greater than 10%, which means it's a bit more than 6 amps, and it is. It's 6.5 amps, and the watts there is 50, no, that's hertz, 1500 watts. So that's all as I might have expected. Okay, let's go back. Okay, now down to 91% on the Bluetti power bank. And inside the car, still 96 miles, 49%. And it says here it is estimated to complete charging at 5:31 in the morning tomorrow. It's about midday, I think. Oh, it's 12:31 now. And that would be up to 90% because I've set my charge limiter to 90%. They call it long journey mode. They recommend you only charge to 80% for normal use, which I guess makes sense for lithium NMC chemistry. But that's definitely bobbing between 3 amps and 2 amps. Still 356 volts. The battery is charging the slowest I've ever seen it, which is not surprising because I don't think I've ever charged at 6 amps. That's 6 amps at mains, of course. 2 2 to 3 amps at, well, I'm tempted to say 400 volts, but it isn't because the battery's quite low, 356 volts. Now my estimate of adding 4 miles to the range of the car, oh, has it gone up a mile? Yes, it's saying, oh no, that's interesting, it says 96 miles on the instrument dash, but over here on the charging screen it's saying 97 miles. So yes, it's gone up by a mile, but the percentage hasn't gone up from 49%, which is odd. Oh no, that's right, it's about a ratio of 2 to 1 at the moment, so you get about 2 miles per kilowatt hour. In fact, you can see the number down here in that grey box at the bottom. I'm averaging 2.6 miles per kilowatt hour. Now that's not very good for this car. This car can do 3.5 miles per kilowatt hour, but I like to have the heater on flat out, so of course a fair amount of my electricity is going in running the heater, and it's not just going to the motor, and I don't mind that. I think it's perfectly acceptable to be in comfort. So I'm getting a low miles per kilowatt hour. I'm getting 2.6. Probably in the summer I'll be getting 3.5 or possibly even better, because I don't tend to do a lot of motorway journeys. I tend to do a lot of local journeys, and electric cars are better at that sort of thing. There's a home screen here which you can get to either by pressing the home icon there, or you can use the physical buttons, which are easier to use while driving. There's a home button there, and that shows the charging. So 49%, 96 miles. That's interesting. That's different from the battery screen. Let's go back to the battery screen. I'm moving a little battery toggle down here. It's got mode for eco, normal and sport. It's got KERS, which is kinetic energy recovery system, or what they call it, regeneration. I can't think of the word. And then there's a battery button, so you can get directly to the battery charging screen. That's definitely saying 96 miles. The home screen, sorry, that was 97. The home screen is 96. Bizarre that there are different parts of the software that are making different estimates of mileage. That's very strange. The radio is tuned to Magic, which is easy listening, I would say, and that's a navigation system. But yeah, you get more information if you go to the battery screen. Perhaps I'll go back inside and have another look at the power bank. But in any case, this works with that simple sort of digital and analog circuitry, CMOS and comparators. Just the 3 comparators. This actually works as a car charger, as an EVSE. Those green LEDs definitely do help. So I can see that those relays are on. Yes, it's all rather encouraging, really. I'm already thinking about what I need to add to this, of course, to take it to the next step. The next step fundamentally is to put an Arduino in here, and that creates some issues because all the circuitry in here at the moment is 12 volt circuitry. When you put a 5 volt microcontroller in here, you need to interface that 5 volt microcontroller to 12 volt circuitry, and that means some minor challenges. Yeah, this screen really doesn't show up terribly well at all, does it? But anyway, down now to 76%, still running at 1520, 1530 watts. Ignore the date, that's completely wrong. This does seem to lose its date fairly frequently. Probably when I run it down to 0% and it shuts down. So we've done about a quarter of the discharge, so I'll do a little bit less talking now and a bit more sitting and watching it. And yeah, we'll run it all the way down to 0. Fair amount of warmth actually coming out of the fan output. So of course you do lose some efficiency in the inverter, but I think taking that into account, 1350 watt hours was about right for this unit, which is the Bluetti AC200. I've just turned the car's electronics off actually by pressing the stop-start switch, and you get a slightly different screen. You get a charging screen there, 96 miles, 49%, but that goes off after a while. On here you can just still see the numbers there. Oh, it's difficult because I'm getting lots of reflections. The screen's all greyed out, 49%, 97 miles. And the worst English I've ever seen, it cannot operate when the vehicle is inactive. Please start your vehicle first, with some very strange full stop spacings. That's terrible, isn't it? You'd think they could have that checked at the very least. Yeah, shockingly bad. I think I worked out that you can get that instrument display to come back on just by toggling the locks here. So if I lock the car's doors, yeah, that comes back on. So when that goes off again in a few moments, I can unlock the car doors and that should come back on again. So a little bit about MG. Of course, MG was a British brand. I think I read the other day that it stood originally for Morris Garages, but they disappeared way back decades ago. But the brand was bought by a Chinese company, and so this is a Chinese car. It's one of the first of the Chinese electric cars that I think are going to dominate the car market in the future. The legacy car makers, I'm sure, will try to keep up. If you look at this badge on the window, that says SAIC Motor, and SAIC is Shanghai Automotive Industry Company or something like that, I seem to remember. Actually, I meant to just see whether this was getting warm. It's not actually. That feels fine. Because the overlap of the pins in here is only about 1 millimeter. The pin goes into the receptacle only by about 1 millimeter, or maybe 1.5. It's really horrible, this thing, but I wanted something with a low profile, as I say, that would fit through the letterbox, but that actually seems to be okay. It is rated for 10 amps and it's only having to pass 6 amps, but yeah, it seems fine. And I thought that was quite an interesting shot from my vantage point here, looking at the power bank. You've got the mains plug and socket dangling out the front door, the commando plug and socket, the EVSE sitting on a piece of wood, because it's actually upside down. The nice shiny top where the display shines through, or shows through, is actually on the underside there, so I didn't want it getting scratched on those flagstones. And then the car just beyond that. Actually, it's a really nice sunny day today. Let's have a look at the export meter from my smart meter. Yeah, exporting to the grid, that's what that pylon means. 3 kilowatts. And of course the car's not connected, so all of the solar is going out to the grid. And actually the grid export rates, I'm on a agile export tariff now, are huge. I think you can get up to 60p a kilowatt hour because of all this geopolitical tension. Yes, the electricity export rates are now very high. Down now to, I just missed 50%, 49%, still pulling 1500 watts. Let's go back into the car and see if we've got an extra mile of range. Right, this display has shut off for some reason, probably because I opened and closed the door. But this display here is showing now 98 miles, and the 49% has now increased to 50%, so it's definitely charging, if rather slowly. Oh, and I just found out that by pressing the home button, it turns the screen on even when you're in power not. There's a yellow light and a green light. Still haven't quite fathomed out what they mean, but both are off, so there's no power at all. But yeah, I never even knew that. I've just learnt that you can get the screen on by pressing the home button, and we can see that, if I can get my shadow out of the way, 50% and 98 miles. So I just thought I'd lift the bonnet briefly. I do believe the mains is coming in here, because you can see brown, blue and green and yellow wires. So I think it's going into, I think this is the car charger, the battery charger, takes mains in and then puts out between DC output 230 to 450 volts at 22 amps max. So I think that's the car charger unit, and of course this has the V2L So this is also an inverter. It can generate mains and put it back out through the front charge socket when we can buy the accessory lead to do that. There's another unit here which I think is just a distribution unit. It does actually say there PDU, a bit of Chinese, and then underscore CAPI, whatever that means, I don't quite know. And electric cars still have lead acid batteries, so there is a good old-fashioned PB lead acid battery, 12 volt, 63 amp hours. I don't think it's anything fancy, it's just, yeah, a lead acid battery, and then lots of bottles of fluid. I think one of these is for battery cooling or battery heating. There's another one over there, that might be air conditioning, brake fluid there, washer fluid there, some bits of aircon there, and this is a fuse box. I don't know whether I should open this. I can't really do it one-handed, but there's a fuse box in the engine bay, not that there's an engine, and there's another fuse box inside, I do believe. Right, power bank is now at 25%. 1560 watts going out now. Let's check the car. Yes, this is pretty much what I thought it was going to be. Can I get that in there? 99 miles of range now, 50% battery, so I do think it's going to just hit 100% when that power bank is fully discharged. 10% left on the power bank, 1560 watts. Now, should I let the power bank just shut itself off when it gets to 0%, or should I do a graceful stopping of the charging from inside the car? I don't know. I don't suppose it matters really. Perhaps I'll just let the power bank shut itself off. Okay, with 10% left here, let's go and see what's happening in the car. And so on the instrument panel, yep, 100 miles, battery at 50%. That didn't change much, did it? Because it started at 49%, it's now 50. Let's come out of there and look at this display, and that's saying the same, 50%, 100 miles. Okay, I'll just allow the power bank to fully discharge and see if there's a graceful shut. Well, it won't be graceful, the mains will drop out, but let's go back to the power bank now. Okay, 2% on the power bank, 1560 watts. I'll just wait for that to drop to 1%, and then I'll run outside and see if I can catch the moment when the relays drop out on the EVSE. Although that doesn't really mean anything, does it? Because it's just going to lose power basically, and you'd expect 1%, you'd expect relays to drop out when they lose power. Let's do that anyway. There are the green lights. That's not going to run for much longer, I don't think. Oh, there they go. The relays have dropped out, so let's get in the car and see what it says. Oh, charging stopped, as you'd expect, because the car is no longer seeing the pulse width, the 1 kHz square wave. At 100 miles on there, how did we do on this display? Oh, the same, 50%, 100 miles. So yes, 1350 watt hours from that power bank resulted in a range increase in the car of 4 miles and 1% of battery capacity. It is quite a big battery in this car. It's 72 kilowatt hours, I believe. But having gone from 49% to 50%, we've just actually gone over the threshold of the third quadrant of this little display, because that started on 2 bars, didn't it? Now, will this come out? Oh, it does, yeah. So the unlocking pins unlocked. I don't think they ever locked actually, because I think it's because the car's unlocked. Up here, the EVSE, of course, is now off, and inside The power bank is at 0%. So that's it. Fully discharged this Bluetti power bank. Got 4 miles of additional range. Oh, those lights have gone green now when it's charging. Oh, that's one thing I didn't look at with my EVSE, but anyway, they're green when it's charging, blue when it's not. It does make sense to charge the car today because it's actually turned into a pretty nice sunny day with reasonably clear blue skies. So what I'm calling EasyEVSE, this simple CMOS and comparators circuit, seems to work. The car seems happy with the 1 kHz square wave. The relays turn on and mains goes to the car. So very pleased with that. Another thanks, of course, to Bernhard Walter for his AnalogEVSE project. I'll put links to that in the description below. But as for my day of testing this, I'm very pleased with the result. Cheerio.